Okay, good afternoon, everyone. So, only 8 people are here. 8 people are here. Okay, however, I'd like to continue my class today, a very important class, and it could be 16 marks question in our final examination. I'd like to take this particular question, or I'd like to explain this particular topic in stage by stage. Okay, step by step. Okay, so likewise, I'd like to so discuss with you. So let us have a look here. DES, Data Encryption Standard. So what is the data encryption standard? How this data encryption standard has been introduced? So already we have taken some information regarding to Fiestel network in the previous class, previous session, and this Fiestel network is always apply so a round function. This round function is pretty much important. So what are the components of round function will be known to you in DES only. So look at this. This is the Fiestel network, and this Fiestel network might have four components. Number one, plain text. This is called as the plain text PT, and this is called as the ciphertext CT. Of course, not exactly single round. It will be taken number of rounds here. Finally, after last round, we could have the ciphertext here. During this, how the things are being happening here in the sense, so it could be taken, so the Fiestel network will be taken one one mixer. This mixer will be having a round function f of r1 comma k, where r1 will be the right side value of the plain text or previous round value. So previous round in the sense, for example, this whole thing will be considered as first round, and same thing will be taken as second round here in the sense. So instead of R1, we would like to write here it is R2. So simply speaking, here it is RI. RI in the sense where I will be the I will be ranges from so 1 to 16 in terms of DES. Okay, R1, R2, R3, and so on and so forth. Okay, however, it has been taken. So the value from R1, 32 bits will be taken into consideration, and it could be performed some operation here. What is the exact operation could be done here? Let me explain today in this class. And then after doing something here, so this particular value or this particular output will be exclusive ORed with left side of the plain text here, and that value could be sent to right side value of ciphertext, and so R1 will be sent to left side value of the ciphertext here. Otherwise, forwarded to next round here. Okay. However, what exactly been happening here as far as this particular function is concerned? Number one, you need to remember one thing. So DES was also prepared by NSA, National Standard Authority of US Defense Ministry in 1974. In 1974, it's been prepared, and it has been used up to 2005, approximately some 30 years it has been used. Okay, still people are using. Already I have given some information to you that all European electronic passports are using only the DES as its so security measure. However, I'd like to give you so what exactly the DES will be. So look at this. So this is DES algorithm, and this DES algorithm can be taken as input. So the plain text here, plain text will be taken as input, and it will be produce the output as finally after taking so complete DES operation. So what exactly you could get here is this is the ciphertext here. And meanwhile, it must be taken one more input. So in addition to plain text, one more input will be taken, that particular key here. Okay. So two inputs will be there and one output will be there from the DES. while it is being done in encryption, ENCR, encryption process. If you go ahead with the decryption process, obviously it could be in reverse mode. The reverse mode will be taken something like this. So it will be taken, so ciphertext as input and provide arrows only here. So provide plain text back after decryption. So here it is DES only. This is DES only. And one more input will be taken in addition to the ciphertext, that is key here. So here we need to know some very important point here while discussing this particular DES. That is, what is the size of plain text? What is the size of the key? What is the size of plain text? What is the size of the ciphertext which is being provided after running this whole DES? And what is the size of this particular key? So these three aspects are very, very important for us. So the size of plain text is 64 bits. 64 bits. Okay. Obviously, if you are give some kind of input to the DES as 64 bits, then obviously output also 64 bits. It's also 64 bits. And what is the size of key here? Normally, if 64 bits will be taken into consideration, people will thought that yes, size of key also be 64 bits. But that is not correct. It will be taken 56 bits as the key in terms of applying cryptography using DES here. So this is a basic structure. The basic structure will be, so look at this, this basic structure will be seen in such a fashion. During encryption process, so it will be taken 64 bits of plain text into account, and the DES is being operated continuously, then followed by after 64 bits, so it could be taken one more input for encryption process, that is key. The size of key will be 56 bits. Okay, 56 bits. So it could be gets operated 64 bits using this particular key as 56 bits. Then it could be so provide after number of rounds, it could be provide ciphertext of 64 bits back. Okay. So finally, the size of plain text and the size of ciphertext will be same. The size of plain text will be 64 here. The size of ciphertext also be 64 here. It is same. Meanwhile, in the middle, so many operations are going to be happen here. Then, what kind of operations could be took place within this particular DES? So what exactly the operations which could be happen at this particular area? What exactly it is being operating here? So next item or next step, we have to elaborate this DES like this. It could be seen in such a fashion. Let me eliminate this one for a while. Let me eliminate this one for a while. Wait. Yeah. So let me delete this one. In the second step, what exactly it could be done here in the sense, it could be, it could be elaborated something like this. So DES could be the DES. It is a DES. Abstract view of DES, here it is. And this abstract view of DES could be taken. This is a plain text, and this is a ciphertext, and this is the key. Okay. Then what exactly could be taken into consideration of this particular DES after the first stage? So what exactly it could be done here in the sense, apply feastal operation for number of times. Apply feastal operation for number of times, something like this. So this could be extended something like this. So this could be extended something like this. So look at this. So this plain text will be whatever the plain text you are expected to give into the input here. So this plain text will be, first step is take this particular plain text and apply initial permutation. There is a standard initial permutation. So initial 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 permutation MUTATION initial permutation will be, I mean 64 bits will be reordered based on the permutation. After permutation, it could be taken, I mean this permutation output will be taken to first round one with Feastel network, Feastel network, FN in the sense Feastel network, followed by, so it could be sent to round two. So so this is round two again using same Feastel kind of network here, and continue this operation for so 16 times. 16 times. This is round 16. Already we have seen a Feastel network will be taken into consideration. If you apply for 3 rounds of operation, then it will be strength. And if you go for fourth round, it is a pseudo random function will be generates very much strengthened key while we are trying to operate in crypto systems. Okay, so that is the point which we have seen in the previous class. So here DES will be taken. DES will be taken approximately 16 steps or 16 rounds. Okay, after this is also done with the PSL network only. After getting 16th round, there might be some output. There might be some output. That output will be so forwarded with one more permutation that is called as final permutation. Final, so permutation. PERMU. Please write in our own way. So final permutation. Okay. So in this way, after taking this particular final permutation, so you will get so the ciphertext. This is your ciphertext. Okay, these are the operations. This is CT. Take this. So okay, take this plain text here. This is the plain text actually. This plain text will be supplied to initial permutation. Your bits will be permitted. So permitted, and after taking this particular permutation, then your of course in Feastel network we have seen. So your data will be total 64 bits will be divided into two halves. So first half is called as L1, and second half will be called as R1 here. So L1 will be Feastel has done some kind of operation. You have remember, I think yesterday we have discussed. Okay. So, however, this Feastel operation will be done here. So, after initial permutation, then it will be sent to round one. Round one can perform some kind of operation. After round two, after round three, and so on and so forth. Of course, each and every round can be taken. Each and every round can be taken a key. So the size of this particular key will be 56 bytes. It must be remembered by you. The size of initial permutation, output of this initial permutation will be 64 bits. So here also 64 bits, and so on. Here also 64 bits, and here the output also 64 bits. And finally, after final permutation, here also 64 bits. Okay. So you have given 64 bits as input to the initial permutation, 64 bits as input of initial permutation. After completion of final permutation, the size of your ciphertext also be 64 bits. In this way, so this is the second stage where exactly the point will be considered here. Then what exactly been happen? What kind of values will be there in the initial permutation? So what is the initial permutation matrix, and what is the final permutation matrix? So what is the final permutation matrix, and how the data will be transmitted from actual plain text to initial permutation, and how the rounds will be took place here. Here input of this particular plain text or initial permutation will be 64 bits, but we are working with a 56 bits key. How this 56 bits key will be elaborated to 64 bits, and how the things are being happening here. we will discuss each and everything by tomorrow class. I wanted to notify only this one because DES will be taken approximately 3 classes. So if I would give this complete information in single day, you could not understand. The point you need to understand here is, I hope that up to this moment you maybe have some clarity regarding to data encryption standard here. Okay, DES will be, let me repeat one more time, a DES will be taken 64-bit as plain text as input and provide 64-bit as output, and the key will be, size of key will be 56 bits. How this could be happen, how next step of DES will be, plain text will be supplied to initial permutation. After initial permutation can be taken, this input will, this output of initial permutation will be given to round one and apply this particular rounds, number of rounds, approximately 16 rounds are being applied here. After 16th round, whatever the output you have, that could be sent to final permutation. After getting final permutation, that is the ciphertext you have, and this ciphertext will be so forwarded to so insecure channel, that is internet. Okay, internet. Here you have to forward this one to internet, and it will be received by the recipient, and he will do some other operation. That operation will be discussed by us later. Basically, we required only this one here. So you need to understand one particular point. You need to understand Fiestal network. You please understand this one here. In Fiestal network, so look at this. So here round function will be there. This round function will be f of so r1 comma k key. Okay, and this will be forwarded. Here it is. We do have a swapper here. We do have swapper here finally. So this is the actual text which is being generated, which is being generated for next round. So take this particular value and forward here, and whatever it may be we have taken here, you have operated exclusive R, and output will be forwarded to next one. So this is so L2, and here it is R2, right? So it would be happen here. So you need to understand one particular point here. You need to understand one particular point here. So what is the size of R1 here? The size of R1, because plain text is being taken. Let me take some other color you could understand very clearly. So the plain text size will be 64. 64 will be divided into 2 exact halves. So therefore it is 32 bits, and it is also 32 bits. So what is the size of this round function could be taken 32 bits. And what is the size of your key? Key will be equal to so 56 bytes. Sorry, 56 bits. So here we are working with this particular round function can be worked out with only 32 bits, because the size of this one is 32 bits, and the size of output also be 32 bits. But you are providing 56 bits as the key for doing this operation. What exactly the operation could be took place? So we need to think of this particular thing and how the things are being happening here. So tomorrow we will discuss about this particular point, the key point, the round function, very much important function here. The key point is round function, how this round function can be evaluated, and how you have increase the number of bits of 50 key, or decrease the number of bits from the key. How these things will be happen will be discussed by tomorrow. So this is what today's class. Okay.